Welcome back. Now let us try to get into another kind of application. Till now we have been matching where we know the test image or test shape. Okay. Now let us see that suppose you have a number of say 100, 200 or 1000 million, any number, and you wanted to know how many natural grouping of these shapes are. It means how many of these are like squares, how many of these are like eclipse, how many of these are like arrow or any other kind of shapes. You don't know that, okay? We'll try to do it using the clustering. First of all, what is the meaning of clustering and these things? I hope you must have, if you see, I had made in the prerequisite that machine learning. So machine learning, the K-means clustering you will learn over here. And if you know the clustering, it's fine. If you don't know, you can search a little bit about the K-means clustering. That should be good enough. But I suggest that you should be knowing it. So what we are going to do, K-means does the clustering of the K clusters. So what is the meaning of K cluster? K cluster is like if you have, if you believe that you have say 5 cluster, 10 cluster and so on. So that itself the number you will learn in machine learning, that how to find it out, that number of cluster. So we are going to do the K-means clustering and we'll assume that there are 2 clusters in the data we have, and we'll be using the data solidity factor. So what is the meaning of solidity factor? See, in PPT I have written at the bottom, I have given a few slides. This is for definitions. So few of the things which we have been learning and which I'll be using. So I have written the definition here so that you know it. So solidity factor, before we know the solidity factor, convex contours we have seen, okay? And convex shapes, I hope you will be knowing it, that it is a kind of which is bulging it out, that kind of shapes, and so this is the definition. So this is, and also known as a closed shapes. So for any 2 points within shapes, draw a line between them, and the line will always lie within the shape. So that is a convex word, okay? So if you see this red color, if you put any 2 points on the red color and draw the line between them, that line will be always within the shape itself. So that red color on the over here, this is a convex, okay, not the green one. Now another term is convex hull. What is the meaning of that? You have seen this arrow we have drawn in the previous classes. So that our actual object is this green color, and that green color is contour, that green color, okay? And the red color on the we have drawn is or a rectangle in such a way, this is having minimum area that encompass complete object. So this red color is called convex hull, okay? Convex hull. And then solidity factor, it is a ratio of the area of the image to the convex hull. So if you see there for this one, what will be solidity factor? The area of this within the green color, that area divided by the area surrounded by the red color. That is the solidity factor. So we are going to do the K-means clustering on the solidity factor. Okay. So now in 136, let us take our original image and calculate the solidity factor. So here we are calculating. Let us show you. So we are iterating for each of the contour. We are getting the contour area, and then we are getting for this contour area, what is a convex hull, and for that area of hull. Okay, so this is the solidity value, that is the contour area divided by solidity, this convex hull, okay, that is the area, and we are simply appending in the list, that is the list we have made it. So solidity value and contour hull area, that we'll need in the future, so that is why we are storing it over here. So 139 till 149 we are running. So this has given the solidity factor for each of the contours. Now we are going to reshape it, because this is solidity values. If you see right now, if you see the solidity value here, it is simply list of the 11 value, but it generally KMeans does not like that. KMeans wants in a bit different way. So 152 I have run. 153, if you see the shape now, 11 by 1, it means 11 row, 1 column. So this is, if I print it, you will get, this is the value, solidity factor. Okay, so this is what it has given us. Now let us do the clustering using the KMeans. These are the few of the criteria that what it is simply saying. It is simply saying this is the some error term, maximum iteration, and so what it is saying, that maximum iteration, these are the things. There are some errors. Let me explain these terms a little bit further. The solidity values we have got earlier. This is the number of cluster. So how do you define the number of cluster? As of now we are assuming it, but once you learn the KMeans detail, then you will know how to get a number of cluster of a set of the data you have. Okay, this one we don't need. Criteria we have explained above. Okay, and this is the error based. What is the error based and all? Probably when you learn KMeans, then you will come to know. Maximum iteration also will come to know in the KMeans itself. And it is saying choose the random center. So what is the meaning of random center? That you learn in the KMeans. The number of times this algorithm will iterate, 10 times. So let us go ahead and do it, this KMeans iteration. So I'm running 159 to 165. It has done it. Okay. Now let us run this one, and then I will show you. So you see what it has done. It first of all, when the KMeans clustering has been done, so it has given this is, if you see, this is the clustering it has. This is the clustering. I'm printing it, label 0101. So we had set the 2 cluster, and that is what it has given, that one cluster is typed as 0, another type as a 1. Okay, if you would have taken 3 clusters, then it would have given you 0, 1, 2. Now we are trying to print this 0, 1, 2 on a different rectangle with different color. If it is of 0 cluster, that we are printing with blue. If it is cluster 1, we are printing with G, that is the green one. Okay, so let us print it 168 to 175 in one go. So whichever is the blue, that is the one. These are the one cluster, and other on the outer side, if you see, this is that has been printed, that comes under the 1 cluster. So what it is trying to say, that all this blue, this probably looks similar, and this image, that looks in 1 cluster. So this is the way to find it out, something in the 1 cluster. Okay. First of all, there are 2 things. You have few classwork. Instead of 2, just try to make the cluster equal to 3. That is where you have to change. This is the part only. That's all. So once you get it 2, then you will get 0, 1, 2. So for say 0, I'm drawing the blue. 1, I'm drawing the green. Then for 2, you can draw the red color. That's all. It will be done. Then you see. Then you say that how this clustering mechanism is good. It's all about. Okay. And now the question comes that can we combine all these 3 methods and try to find it out the match? Yes, you can. So let me show you how. I'm trying to run that. See the picture again. 175. So if you see that all this outer side, the green one which we have, if that forms into 1 cluster, it means they are of the similar nature. So if we take this 1, 2, 3, 4, 5 and 6. So this 6 we take it and then try to run the match algorithm or the number of points, convex points. Then probably you will be able to figure it out that when you do the match of this one, this is exactly similar to this and this. Okay, so this is the way you have to use the multiple technique to really find the similarity. And this is quite useful when you have say hundreds of images, 1,000, million and so on. Okay, so this is one of the way. And 180 we are simply doing the cleanup, that's all. And for this one that's all. And in the next video I will explain little bit more concept about the contours, which are quite useful in doing the application of contours in the different computer vision applications. Thanks a lot for watching it. See you in the next one.